Integrated activity planning is a complex activity in most upstream oil and gas assets, but critical for operational excellence. This demo shows how we are applying our unique game AI approach to support asset teams in optimizing maintenance plans. One of our clients asked us to look into their maintenance planning philosophy. They were facing a large portfolio of work but did not achieve the required execution efficiency. So, backlog was building up. The number of permutations in their day-to-day maintenance planning is enormous, with tens of offshore locations, thousands of work activities, and a constrained execution capacity. Our game AI approach really suits these kinds of complex problems and can help the support planning team to make the right decisions. In this demo, we created a scaled-down but representative version of the maintenance planning game. We developed an AI assistant that can play and master the game. We tested the logic and robustness of the game with a number of different scenarios, and already identified the potential for significant improvements over the existing planning philosophy. This is really exciting and demonstrates an opportunity for the industry to get much more value out of high-cost maintenance resources by artificial intelligence as planning support. In our unique approach, we create a game that reflects the complex problem, including the associated rules and user-defined scoring system. We develop an AI assistant that can play the game. With any action of the assistant, it receives feedback from the scoring system. By playing multiple actions in thousands of games, the assistant learns how to master the game by developing optimum policies. These policies can be evaluated through different metrics or KPIs. We can then test alternative scenarios by changing the game, its rules, or scoring system, and let the AI assistant develop alternative optimum policies. These iterations give a deep insight and understanding of the trade-offs and therefore lead to better decisions. In this maintenance planning game, the playing field is determined by the portfolio of work activities and associated work locations. We have a number of rules, such as the number of hours to plan per day or the skills composition of the maintenance crew. The scoring system is user-defined and can be based on the different priorities for each type of activity, possibly awarding bonus points for executing activities on particularly important locations. The AI assistant then needs to make a series of decisions to create a plan. To which location does the boat need to go? How long does it need to stay there? What activities should be executed? And the objective of those decisions is to maximize the number of points or reward in the game. By playing the game thousands of times, the assistant finds series of optimal decisions. These form the maintenance plan. The AI assistant supports planning teams by building an optimized plan for a set of rules and for a particular scoring system by choosing location, duration, and work orders. We then use KPIs to look at how good that plan is through different lenses. Example metrics we use in this case are crew efficiency, number of visits per location, and number of work orders executed by priority. These KPIs give insight into the plan and the underlying rules and scoring system. We can then change these elements and play the game again to evaluate alternative plans of planning philosophies. Using a similar AI assistant on an operational level would give teams a much better ability to deal with competing value drivers and continuous change. The demo game already gives insight. Our AI-assisted planning gives a much higher crew efficiency compared to the client's current manual planning. A huge opportunity, therefore, to get more value out of very high-cost maintenance resources, and a step closer to real operational excellence. White space energy. Navigating complex decisions in oil and gas through game AI.